I mentioned earlier, we have built the tree out of the records that we do have. That's going to be our learning set of objects. So we're going to train our tree or our classifier with by allowing it to learn from the data that we have available, and we're going to learn and learn the descriptions of the classes and build the tree. Once we have built the tree, we can use a testing data set to test the tree, how accurate it is. Oftentimes, if we don't have, we would just have a single data set and we'll split it into two parts and use like 60% to train it and the other 40% to test it. That would be records that it hasn't seen before to evaluate its accuracy. So how well it works. There are various algorithms and software that exist that allow us to build these trees. We will look at this ID3 algorithm. So we're going to do an example of that. There is a bunch of software that exists, C5, Orange, Weka, RSES, and many other data mining tools that exist which have these decision trees built in them, SAS, Data Miner, and many others. Let's look at an example with medical data. This particular tree will predict whether the patient will survive or if they will die after they had a severe trauma. So that's a data set of patients that experience severe trauma, and we have built the tree. Our decision attribute is whether they will survive or whether they will die. And these are some medical exam records in the data. So here it says if the value of this attribute is less than 7.2, then the patient will die. If it's more than 7.3, they will get well. If it's between 7.2 and 7.3, then we have to check the value of this attribute. If APPT worst is less than 78, the patient will be well. If it's more than 78.7, then they will die. So what is this attribute? This is worst pH value. This is worst active thromboplasm time. So these are some values of medical examinations that was performed on the patient. That's another medical data that shows when we have breast cancer, if it's after the breast cancer has been treated, if it is likely that the breast cancer will reoccur or if it will go away and be cured. And so, first attribute that was used, degree of malignancy. If it's less than 3, then we have to look at the tumor size. Tumor size is bigger than 15. There will be no reoccurrence, 125 times, and reoccurred 39 times. If it's less than 15, we have to check the age. And so on. If degree of malignancy is bigger than 3, check the involved nodes. So no recurrence, 30 patients recurred in 18. So this kind of tree can be used to help doctors in their diagnosis. So it's a decision support system in essence for the medical doctors in this case. That's another tree for prostate cancer. Whether the prostate cancer will reoccur, yes or no. Again, we're just looking at some attributes, splitting the tree. So secondary deletion grade, PSA level, stage. If this is 5, then yes. If it's 4, we have to check the stage attribute and some other values in order to make the decision. Now, I mentioned we will look at, we're going to do an example of the ID3 algorithm. And this is pseudo code of how this algorithm works to construct the decision tree from the learning set. If all the examples or objects belong to some class C, then we make a leaf and label it C. So the class is, for example, yes or no. If all the objects are yes, we're going to create a leaf for them. If not, we're going to select the most informative attributes and partition the objects into the number of values that this attribute has. And again, check each of the partitions that we created. If all the objects in a particular partition, T1, are of the same class, then we create a leaf. If they're of a different class, we have to keep splitting until we arrive at all leaves at the bottom of the tree everywhere. So we're going to recursively follow this procedure until all of the ends of our tree are made up of leaves. So until we have leaves everywhere in the bottom of the tree. So again, we will pick the most informative attribute. And what do we mean by the most informative attribute? We will see in a second. So we have to make a decision which attribute to use because it makes a difference of how our tree is going to look like. So we will check if all the objects are the same class, we create a leaf. If not, we will pick one attribute and split in the data into that many pieces as the number of values this attribute has. So in this case, T1, T2 to Tn. For each subtree, we're going to do the same thing. If all the objects in here are the same class, we create a leaf. If not, we will keep splitting them. And the same for all of the subtrees. Let's look at another example. So this data says whether the child should be allowed to play outside or not, according to how the conditions look outside. So we have outlook again, sunny, rainy, or cloudy, and the temperature, hot, cold, or moderate, the humidity, and whether it's windy or not. And then the tree will help us to make a decision where the child should play or not. That right here is a very beautiful tree that was created from the data. And when I say that's beautiful, it means that the tree is not very deep. So it's easy to find the answers or to get to the knowledge. If we start from the top, it's pretty quick to get to the leaves and make the decision. So if it's overcast, play. If it's rainy and windy, then don't play. That's easy to get to all the rest of the the leaves. This is a tree that was created from the same data. Again, it has leaves, but as you can see, this tree is not as beautiful as the first tree because it's a very complicated tree. It takes a long time to get from the top to any of the leaves to traverse the entire tree. So it makes a difference of what? Which attributes we're gonna pick in order to split the tree next. But we have to make an informative decision. We're gonna use the most informative attribute that allows us to get to the leaves as quickly and easily as possible, is the idea. So if we pick the wrong attribute, we can end up with a huge, deep, and messy tree like this. So there are certain formulas and measures that we can use that will allow us to choose the best attribute.